Well, hello, everybody. And thank you to Mary and the gang earlier for being on the stream on IBM Developer Twitch and the other platforms too. But I am taking it over. My name is JJ Asgar, and I'm a developer advocate for the IBM Cloud. And today I have the privilege of bringing in Ken. Hello, Ken.
Hello.
Hello. And Clint. Hello, Clint.
Hi, JJ.
How are you guys?
Doing
Doing
great.
pretty good.
Wonderful. So I didn't actually say what we're doing because I figured what better way than Ken? How about you introduce yourself and then tell us what is our goal for today's stream?
I am Ken Bingham in Charlotte, North Carolina, and I'm a developer advocate at NetFoundry. And we're going to be installing ziti and Kubernetes.
Okay. And Clint, who are you?
I'm Clint Ovlock. I'm also on the East Coast in Rochester, New York. I also serve a lot of the developer advocacy role. I really care about our developers, and I'm one of these crazy guys who actually likes to write documentation and examples. So I actually work on the team that builds this ziti thing that we'll end up talking about today.
Awesome. Well, as I realized that I had a massive screen and the problem of what I was looking at. So yes, today's goal is we're going to be building something using Kubernetes and Ziti. So how about let me share my screen real quick and bring up the Ziti website. So who would like to take it and tell us what Ziti is and why it's so cool?
You want to take that one, Clint?
Ken, I think you're all on this.
All right.
I know you get this ready.
All right. So ziti is an application delivery platform and a programmable overlay. So you can zitify your application, and then it behaves out in the world based on who it is, not what it is. And I'll explain what I mean by that. So if you couple your application with a ziti identity, then it's allowed to connect to and be connected to by the things that you've programmed your overlay to allow. And it's then less dependent upon rigid network infrastructure or other specialists who might have to program firewall pinholes and things like that. What kind of questions does that raise for you, JJ?
Yeah, and Ziti is also all about actually taking zero trust to the next step, right? When you think about zero trust, people oftentimes think about accessing the network, and sometimes that comes along with strong identity. But Ziti takes that strong identity one step farther and puts that strong identity directly into your application itself. So every application that you, I think Ken used the term Zitify, every application that you end up embedding Ziti into has that strong identity baked right into it. Why that's really cool is because now with that identity baked into the application, you can pick your application up and move it anywhere. It's no longer beholden to firewalls or anything. All you need is an outbound internet connection, and you have strong identity, secure zero trust wherever you go.
Nice. That sounds really so you literally have the opportunity to run your app in the environment that it needs to run to be the best and still have access to the resources. Oh, so I'm assuming like in a
Well, actually,
microservices.
so
Go ahead.
access brings up a really great point, right? So
Mhm.
zero trust, one of the major drivers of zero trust is something that we call microsegmentation, which allows you to actually control what that identity has access to. So in a classic application, let's take an iOS or a Android type app, a mobile application that's going to be talking to the bank. When you talk to the bank, there's oftentimes going to be one or many services that application needs to contact. Those services that I already use this term services, but most people think of them as like REST-based services. Something that's on the web being served by the web. With Ziti, it's actually I think really cool because it's not just about HTTP; it's about any kind of access. So if you have gRPC, for example, you can embed gRPC into your application. you use Ziti on top of that, and now you don't have an HTTP layer. You simply have a raw socket that you're writing gRPC into, and on the other side is a secure connection all the way to your server. So what's really neat as well, you can take that SDK and bake it not only into your client application, but also into your quote unquote server application. And now you have an encrypted tunnel that goes from your process space in your application all the way to the process space inside of the server. So at no point have you left the process space of your application itself. And why that's really neat is because generally speaking, and we have agents that you install, so we have this thing called Ziti Desktop Edge for Windows or Mac, and Ziti Mobile Edge for iOS and Android. These are like bolt-ons that you add onto your operating system. They're the agent that you usually see when you have a VPN. You get the little VPN drop down. Well, when you embed that into your application, there is no VPN. It's literally baked into the application itself. So delivering the application delivers this micro-segmented VPN specifically for your application and only your application. And that's amazing because now you no longer don't trust the network. You don't trust your host machine either. So if there are applications which are tangential to your application on that machine itself, and one of these other applications gets compromised, well, they cannot send data to that far end of the of the server client relationship. You have to be in the process space of the application that has been zitified. So it makes a lot of these ransomware type attacks, so far effectively useless against something that is protected by Ziti.
That's really cool, man. Like, no joke.
No, it
So-
is. I agree. So I work for NetFoundry, which sponsors this OpenZiti project. So ziti.dev, as you're showing here, is one of the landing pages to get to our GitHub page. Everybody can go check out the GitHub. We have a couple getting started guides. We have a discourse to make it easy to get up and running. But at the end of the day, I've drank the Ziti Kool-Aid. I really have, because it is really cool. And no matter where you go, if you bake this into your application, what was it? I had so we recently we zitified SSH, and so you can go out and look at the blog post about zitifying SSH. But that zitified SSH was really cool because I was sitting here on my local machine, just typing away in my home network, and then I just picked up my computer and I went to Starbucks, and it all just kept working. So it's really neat stuff. And when it's baked right into your app like that, it's just the most amazing thing to be able to pick it up and go somewhere else, not have to worry. Like you don't have to tell your mother, hey, when you go to the hotel room, make sure you're on a VPN, right? Like all of those kind of
Right.
commercials just go away.
Yeah, I mean, if
nice.
I was going to build something now, I would definitely use this approach. If I was going to build a mobile client with a server stack, then I wouldn't want that server to be exposed to the internet unnecessarily. I'd put it behind the ZD fabric so that it's available everywhere, but not can't be attacked from anywhere except the particular ZD identities that I have already trusted, already authorized. And I would just bake that ZD SDK right into my mobile app and and then it would just be able to talk to the server, and I could handle things like load balancing and high availability and stuff through that as well, and make it always available and very resilient.
And
So,
JJ, it's okay to just bounce around, right? Like
oh no, please.
one of the things Ken said there that triggered me also that I've also said is, everybody thinks about the classic server when it comes to an application to server, right? Like that's how it always that's just what comes to mind if you've been doing development forever. One of the more interesting things that Ziti has is it has this concept of identities that we talked about, these strong identities, X509 certificates. When you communicate on the Ziti network, you not only verify the certificate that the network presents, but the network also verifies your certificate. So before you even access the network, you've already been authenticated. Once you've been authenticated, you then need to be authorized. And that's the job of the Ziti controller. So the Ziti controller will inform you what services on that Ziti network that you might have access to. Um, and so one of the things that I think is really neat is when you dial that server, you're really just dialing an identity. So in my local machine, I don't know where that server is. It could live in the IBM cloud. It could live in some other person's cloud, right? It could live on my laptop. And this is actually where I was going, because if what's really neat is if you have this point-to-point type of communications, SSH being one of them, obviously it's a point-to-point thing. We can actually dial that identity. So dial meaning establish an outbound connection to that machine, even though I don't know where it is in the world. I can establish that socket that basically layers SSH on top of it, by dialing the identity itself. So if I named the identity, say JJ, I could go to
Mhm.
SSH, and instead of SSH, I would ZSSH JJ,
Mhm.
and then I would just be able to SSH to your machine. So it doesn't have to be just like the classic server that we always think about. It could be straight to the endpoint itself that you're trying to access. I think that's also pretty neat.
JJ, I have
So
a version of this slide that has a couple of summary texts on it. I'll send over. Just to simplify this, since there's a lot of words on that graphic, on that infographic, uh, describing it as a stack with three main parts is helpful, as a helpful summary. And the bottom two parts are Ziti open source project. So you can potentially do all of this self-hosted without NetFoundry in the picture. But NetFoundry adds lots of cool stuff, lots of automation and lots of assurances and lots of things that enterprise and any kind of business case would probably demand, as well as plenty of conveniences and lots of tools. So you could say that your data payload, is coming in and out through the edge or staying inside of the edge domain there, and that's where all identity and permission and the transport is happening. And then there's this ZD Fabric adaptive permissionless mesh that's in the middle, and that's typically hosted by NetFoundry, but you can do it yourself too by running ZD routers in places that are reachable on the internet. And then the NetFoundry platform, of course, it brings that orchestration API to the picture so that you can automate anything that you can do inside of the web console.
Yeah, or if you don't want to do it yourself, you just let the console do that. But JJ, you had a question. I think we cut you off on.
yeah, and again, this is so unfortunately I have somebody deciding to bang on a door beside me, which is always great.
Oh,
Um,
wow.
yeah, it's a story of my life as a streamer, right? But no, my biggest question about all this. So everything you just showed me is pretty damn cool. I'm not gonna lie, it really is, especially the trust to be able to create this network with so little overhead. Well, I use that word overheads very specifically there. Can we talk about like, I mean, talking across the internet takes a while, right? Like in general, there's a lot of unknowns here. So how does that work? Like if I have my database over somewhere else,
Yeah,
obviously I'm not going to want to. Like, can you talk about the overhead and the latency and
yeah, I
what
can
what
definitely
having this level? Yeah, go ahead.
Yeah, I can definitely tell you how I think about it. Like I can imagine that there will be some real-time applications that have very narrow and rigid requirements for which they must be optimized for overhead. And it would just be a case-by-case basis whether adding an overlay to that picture is a deal breaker. I tend to suspect that it's not going to be in most cases. That it's hard to imagine applications that wouldn't be able to tolerate the amount of additional latency that would be introduced. And it just adds another degree of complexity, but it's certainly doable with the existing tooling to optimize that fabric for delivering a specific application in a specific way. And
So
so that's
yeah,
something we
and
can talk about a little bit deeper later, but there's configuration that you can do to kind of steer the traffic in the way that's optimal.
yeah, and on top of that, I mean, a very non-trivial amount of work has already gone into picking the best path, if you will. And we have done internal tests that show throughput. So latency is not the same thing as throughput, right? So we've done lots of tests that show our network doing better than the open internet, almost always beating
Right.
open internet. In some places destroying the open internet. But but there are some times where the open internet and just TCP is, 5% slower, right? Like
Yeah.
that's just noise. And we have a fellow, Michael Quigley, who does all that work, a really talented engineer, and he refers to it. I love the term as the internet weather. Right. So
Exactly.
depending on where you are, the internet's weather can be good. It could be bad. And in fact, JJ and us were just talking about his internet weather. He has a friend who streams with him who's relatively close and says that, he's got perfect streaming, but JJ once in a while has some troubles. So it's a
Well,
great example of how that could work out. But that
So
fabric that Ken had talked about, sorry, Ken, I'm trying to just slip this in. That fabric that Ken had talked about actually already is doing round trip calculations. It has baked into it, what is the fastest route from here to there. So if you take one of our, we call them routers, if you take one of our routers and you plop it down right next to your service, and then you put some, say, tangential routers around the world or around the state or whatever, however you want to think about it, the geography,
mhm.
that fabric is constantly monitoring everything. And what is really mind blowing to me is, you go into command line, ziti list links, right, and that'll show you all your links. It'll tell you your current latencies. It's so amazing to me how many times it's faster to take 2 hops to someplace than it is going straight there. So like a lot of times you'll onboard onto this router, it'll bounce to that router and bounce over to here, as opposed to just going straight from here to there. But that's the calculations that work, and it is just adding up the total path time. It's very naive right now because that's what we have is the total path time, but it finds the quickest one and sends your traffic down that route.
smart routing. That's the adaptive piece of the permissionless mesh. So you basically have like on ramps and off ramps with the edge piece. So you can configure how you get on and to and off of the ZD superhighway, but that mesh
Nice.
topology is adaptive. So it'll go around internet weather, and you can always add points of presence for that overlay according to your needs, like cost benefit, right?
Rock on. That's really, really cool. Okay, so we've talked a lot, and one of my rules about streaming is we need to on keyboards as quickly as possible because we got to show off your awesomeness here. So who wants to start this off? Ken, is this you? Do you want to start
Yeah.
showing us some awesome things?
Yeah, I'll show
And
you some
by the
stuff.
way, at the audience out there, I even have some Zetified stuff that Ken has given me, or at least I've gotten access to. So we might actually build something really cool off of this through multiple clouds and maybe some laptops. I'm real excited. I'm real excited.
All right. So
The networking nerd in me is like really, really excited about this stuff because how many times of my life have I spent trying to get this networking to work?
I guess I'll switch over to a quick diagram so we can just talk about what we've already built, and so we can figure out where to go from there. And okay, you should be seeing my whiteboard now.
Yep, that's good
So
stuff, man.
we've got 2 Kubernetes clusters. Let's see, we've got JJ up here, and we've got Ken down here. And so the current situation is that these aren't connected at all. I've installed some ZD stuff in mine, but he hasn't installed anything in his yet.
Mhm.
And so we're the overall objective here is just to get some stuff talking to each other. And this is a little bit of a layout of how that what those internet connections look like. So you've got ZD stuff inside a cluster going out through its NAT or public IP to the ZD fabric, and then it finds its way through the ZD fabric, and the depending on whether you're calling or being called, a ZD piece is going to be creating these links so it can send or receive traffic. So I've got some Kubernetes icons littered about here to illustrate a couple of different things we could do, and we can just do whatever seems the most interesting to get started. But way on the other side, just to cover the bits and pieces of the diagram, this is just like Bob over here has could be running a laptop with a ZD agent installed, and they could access anything that we decided to expose in one or both clusters. So any questions about this diagram? I can tell you what the different arrangements of ziti and Kubernetes pieces are. Here we can go through those.
I say we see it work.
Yeah, I was going to say, like, this is really cool and all, but I'm a skeptic, and you know, I got to see proof in the pudding. Isn't that the term? Proof in the pudding, something
Definitely.
like
All
that.
right.
Yeah.
All right. So the first thing we're going to do then is we're going to install ziti in Kubernetes. So this is what we're going for here. Helm install ziti. And so I'm going to show you a little bit of setup, and then we'll actually run this command on my computer, which is currently tethered to my Kubernetes cluster.
Does
And
JJ need to run this too?
actually, we could have JJ do it first, and that'll be that way. He'll be hosting an app, like a web app, in his cluster, and the result will
All right.
be that the ziti and JJ's cluster will be able to reach out to whatever is installed there and serve it up to the ziti network. All right, so let's switch over to your screen, JJ, if you don't mind driving for a minute,
Sure.
and we'll have you visit the NetFoundry Helm charts repo.
Do you want to just throw that into the private chat so I can just
Yeah.
bring it up? Just to make everyone see this, and I'm sorry it's too small. This is just a brand new cluster on the IBM Cloud, as you can see up here. Nothing up my sleeves. This is completely empty. I can bring up the dashboard and all that, but I've purposely done absolutely nothing to this to make sure that
Right on.
we are doing this completely empty. So if I go over here and I go ahead and log into the cluster config here, as you can see there, get nodes to make sure that we're actually connected. And then do K. As you can see, I spun this up 25 hours ago. Get pods. There's nothing in the default namespace. And so, I mean, obviously there's nothing going on here. So that's exactly what we wanted. Oops. If I only knew how to do this without having to move the screen. All right, so here we go. We got some Helm charts right here. So I'm going to go ahead and I'll make this a little bit bigger. Go ahead and put this right here and that right there. So we'll go ahead and repo add this Helm chart, I'm assuming.
Yep.
All right, and then search for it just to make sure it's actually there.
There you go. So I'm going to have you first just do the Helm install NetFoundry Hello toy. That's just a toy web app that we'll use that as a target as an example of something like an app running in your cluster that you want to expose to authorized clients.
Yeah, all right. That looks pretty good.
All right, cool. So you're not able to access that directly right now because you haven't done what would typically we would do with the Kubernetes CLI is a kubectl create deployment or kubectl expose, like as a load balancer or an ingress controller or something, or node IP. But in this case, we want to do it privately. We don't want to just dangle it out on the internet, and we don't want to set up VPNs. We just want to use ziti. So to expose it, we're going to need to install ziti in your cluster also. And so the Helm chart is the Helm install command is just like it's shown there in the example, install a chart. But you're gonna need that enrollment token file, and that's in your email. If you'd be able to just download the JWT attachment from your email, and then you'll need to reference that as a file with that command.
And so the JWT itself is part of the enrollment process. That's how we generate that strong identity that I had referred to earlier. So it's just a JSON web token that will go through and basically create a CSR and send that CSR to the server to get signed. And then you'll have a private key on that machine and a certificate that can authenticate you into the network.
Yay, PKI handshake. Yep. So we're going through the process now of minting the identities. I've done that on the back end, and we can explain it later. Just sort of conserving some details, but um, the this CD identity is the thing that's going to be allowed in, to host this particular service, and that service is your toy app that you installed.
Oh, of course, it's not working how I want to.
Oh yeah,
Um,
that command doesn't like the shell expansion. You can use a home or
feature request. Feature request.
yeah.
Cluster.
There you go.
The host one and role.
That's the
So
right
this
one. Yep.
so these are, let me go ahead and make that smaller so we can all see it. So this JWT is created from the control plane. So if we were using some type of like configuration management or like Ansible or Chef or whatever, we would have to create each of these and then put it into the system. So if I decide to spin up a VM or something like that, we would have to do this every single time. Is that correct?
What you'd probably do is mint an API account for NetFoundry or for the
Okay.
controller management API and give that to Chef so it could
That's
provision the identity and then load it into the configuration.
Yeah, that's one way to do it. The other way to do it is Ziti supports third-party certificate authorities. So
Ah,
if you
Oh
wanted
yeah.
to mint your own certificate authority and then present a certificate that was signed by that CA, you're good to
mhm.
go there too.
Nice.
That's more of the IoT kind of a way to do it, where you
Mhm.
don't want to, hands-off kind of approach. But yeah.
Yeah. I could see like already the IoT story of like a bunch of Raspberry Pis like in a factory or something that you just like power on and it net boots off of your network and then add like your local network to the OS and then ZDify it and then all of a sudden it
Yep.
shows up on a big like war room screen of like aha that thing's coming up and going and then you know how many like hamburgers you're making every hour or something.
Yeah.
I don't know.
And the certificates also, we have some basic support for reading the properties of the certificate. So,
Nice.
like the common name or whatever. I don't remember exactly what we use, but that's how we'll name it back in the control plane. So we
Yeah.
have some support for that sort of stuff too.
That should be really powerful if you, especially if you need to do a few 100,000 of these things. Um, or
I don't know. I don't know. I like doing the same thing every single time, just like
it's a
hitting a
lot of fun
button.
for you.
I've
You're
actually
so fortunate,
seen it.
that you're amused by
Made a
these
long
things.
career out of it, huh?
I've actually seen some engineers where when I used to actually work in an office, I still remember the keystrokes of this one engineer because he did all day. He did the exact.
Yeah.
He
Oh
refused to script
wow.
it, so I could actually tell what he was doing because he played
Click clunk, click
his
clunk.
key. Yeah, it was like a keyboard to him. And I was like, I get it, but
You're in your
this
happy
could be a
place.
bash script. Yeah, this could be a bash. I mean, come on. Anyway, okay,
All
so
right. So
we've
that is
deployed the
successful.
host. Yep.
That's good.
I was hoping that you
You've
had
done
the
your end of it.
customary XKCD ready. The
Oh yeah,
All
I
right.
do have it somewhere. I can follow it.
I'm gonna switch over to the console here so we can use that as a visual aid for what's going on the back end.
All right.
And so, and while I'm doing this, if you want to load up the ZD agent on your laptop from the other email that I sent you last night, that is going to have a basically the client side permission for
There,
accessing the
there
toy
we
app
go.
that's running in your web server.
Uh, I'm connected with a desktop edge here with JJ
Awesome.
laptop one. Is that right?
Yep, you're all set then. Just leave that running and we'll come back to it. So
Okay.
here on my screen, we can actually see that your laptop there is registered. So we're just provisioning identities. They by themselves, they don't have any permission. It was just so that they can be known by that PKI handshake that Clint was talking about. Strong cryptographic identity, one identity per thing, per device, or per process, depending on how you're doing it. In this case, the one that you just installed is right here, cluster ZD host. And there's your laptop. And I've assigned using attribute-based access control, this hashtag role attribute, work from anywhere, which is basically just saying you're floating around the world, and we want you to be able to access what you're allowed to access no matter where you're at. So I'm going to click in the left sidebar here over to services, and we're going to create one that describes your little toy server that you installed in your cluster.
Hey, it's production. It ain't no toy.
All
Production.
right. So I'll explain what I'm doing here. We're going to give this a name, JJ's Extremely Production.
Nice. Nice. I like it.
All right. We're just going to give this one a welcome wagon attribute because I've already got a policy set up to grant access to services that have that label. We're going to leave encryption turned on. Don't need to change any of those defaults. And this is a kind of a fun one because you can invent your own domain names. So this can be extreme.server on port 80. And we're going to say that this guy we're configuring like the terminus here of the service. Tell the network where to bind it. So in this case, it'll be hosted by JJ Cluster ZD host. All right. So now we're describing from the perspective of that identity. Oh, did you have a question?
Yeah, and I just want to kind of reiterate for the people who might have just jumped in now. So what we've done is we've installed the ZD agent on a Kubernetes cluster, and then I have installed it on my laptop. So we have no egress domains set up
Right.
at all. We are going to be doing this all through the control plane of ZD. But I want to make sure this is clear. What we are looking at right now is the Net Foundry sugar
That's right.
on top.
That's
You
right.
could still do this with ZD open source, but it's not as it's a little bit more probably texty config file based.
There are actually two ways you could do it. First way is if you like to text and you like to type, you can use the ZD CLI. So
Mhm.
there is a command line interface straight into what we call the ZD controller. The second way would be there's a REST interface that the ZD CLI uses. You could use the ZD CLI or the REST interface. And the third way is there's something that we call the ZD administration console, the ZAC. It's like the bare bones, no sugar UI, right? It'll let you do
Yeah.
all the things through clickies, but it's not as nice as this. So
Got
we
it.
do have a UI if you want. I'll send you a link that shows you how to do all this through Amazon because I haven't generically created a page that basically will take you through actually setting up your first controller, your first router, as well as the ZAC, and it's like a 5-minute step. I'm sure we could do it right here.
Oh,
Absolutely. And to be
that would
perfectly
be
clear,
awesome. Yes.
we absolutely want to celebrate, champion, assist with doing this the self-hosted way. We want to make that convenient and great. Just like the NetFoundry case just adds like enterprise features and all that other stuff we talked about. So I'm going to finish up the service definition here at the bottom of the form. This is an important piece because we have to describe the app that you just installed from the perspective of the other pod that you installed. What does that mean? We're going to use cluster DNS, Kubernetes DNS conventions. That is the Kubernetes DNS specification. When you did helm install hello toy, that created a cluster service as part of the Helm chart. And cluster services are accessible via Kubernetes DNS in a conventional way. So we can actually predict the domain name. I believe the default metadata name was hello.netfoundry. But while I'm doing this, you can say kubectl get services and just make sure that the service that it created is in fact hello-netfoundry.
All right, give me 2 seconds. Sorry, I'm taking notes over in the background here. Just for completion's sake, I'll bring my video back in here.
Yeah.
And you say kgetservices.
Mm-hmm.
That looks right.
Hello-netfoundry. Cool. So hello-netfoundry is the domain name inside your cluster, and it's in the default namespace. So hello-netfoundry.default.svc is a standard Kubernetes domain name.
Mm-hmm.
in the cluster.local hosted zone.
Yep.
So that's what I've typed in here. And your cluster service is listening on port 80 inside your cluster. All right, so
Yep.
I'm going to
Now
click
you
create.
match those ports, Ken, but obviously if you don't want to match the ports, you don't need to.
You don't have to, no. These are arbitrary. We could just make this one 8080 for giggles. Just don't let me forget that I did that.
Oh, that apostrophe got you in trouble.
Hey, at least it tells you why it failed.
That is a very good point. That is a very good point. How much of my life I've wasted by
right.
Stupid apostrophe.
So now that I've done that, we can go and I can check on my tunneler here and see if it has picked up. Yep, that looks good. So I should be able to go to HTTP, what was it, Extreme Server?
Yeah.
8080.
Oh, that's right. See, I did forget.
Mm-hmm.
There's
nice.
a domain name that doesn't exist that we just invented. Basically, just wire up whatever you want from anywhere to anywhere. And let's switch back to your screen now because it should be working on yours as well if you've got that agent running.
This is, I don't, I'm a skeptic. All right, hang on.
I better go make sure I granted the right permissions while you're doing that.
All right, here we go. And then I'll go over here. Actually, you know what I'll do? Close that, and I'll bring up a private window because, computers. So extreme.server port 8080. Oh, come on.
It might make you type the HTTP since it's not sure if you wanted to search.
Well, it's not a top level domain, right?
Right. It's not a real top level domain.
Dot server is not a TLD. So
all right. That's really effing cool. that's awesome.
So there's a container running in your cluster that you and I both reached. We just created a very, very narrow, specific application network and delivered that application to the devices that we authorized. And we did it with attribute-based access control. So we could use automation to span that out to thousands and thousands of endpoints if we want, and we can revoke those on the fly with like endpoint management software integrations and things like that.
So if Ken comes along and if Ken spins up another little app real quick, we really are multi-cloud because we have IBM Cloud, my laptop, and then AWS, where I can talk to there. And now all of a sudden, it doesn't matter where my app is running because it's all on its own overlay network with its own domain. Like I could.
Yep.
This is amazing.
Yep.
Right? Like this is not supposed to be this easy.
It is that easy though, isn't it? It's amazing. And like you said, your own domain. That's to me, one of the coolest things is you no longer have to worry about registering your own domain names, right? You just invent them.
I mean, as dumb as easy it is like your internal wiki or whatever, right? For your company, you could have it sitting on a machine with no access to the internet and do all this, or access to the internet.
Outbound.
Thank you. No outbound access in a data center somewhere, secured.
Only outbound.
Oh my goodness, this is wow.
And now what's really neat is because, like Ken said, with that attribute-based authorization, if he did make that second service and gave that second service the correct attribute, as soon as he makes it, your client will have access to whatever the new services that he provides. So you don't have to go and touch a whole bunch of endpoints either. When I make my services myself, just like you with your JJ's awesome, totally not production network, I make a Clint, Clint's endpoints, and I make a Clint's services, and then whenever I want my endpoints to get access to a new service, I just give the service the correct attribute, and I don't have to worry about anything. It just all goes together.
This is bonkers.
And I'm gonna run an application over on my side so that you can so we can wire our clusters together.
Okay.
You've got the toy app running on, you've got an extreme, very almost production, non-production, truly not production, a web server over on your side. I'll install httpbin on mine. I've just done a kubectl expose to create an httpbin listener inside my cluster on the 80, and now I'm going to create a deployment with the httpbin container, which is a little REST server for testing, and it has one useful function I want to employ today, which is the IP echo. So it'll tell you the IP address of that the request originated from, the HTTP request originated from. So let's take a look at our pods. We have httpbin is up
I see.
and running.
I see you're a professional Kubernetes developer because you have a crash loop back off going on right now, and it's restarted. So
Yeah.
it's nice to know I'm with professionals over here. It's good stuff.
Yep. I didn't clean that one up because that we're all about the warts here. So so yeah, I'm gonna go back over to the console now that that's up and running. I've already got a ziti host on my side, so I've already done the helm install ziti that you did on your side. Only I did it with my own identity. So where is that identity?
The ziti host is obviously namespace bound, I'm assuming. Could you do it host bound? So like a daemon set or something to
Right.
run this across your whole cluster, or what's the best way to do that?
So if your Kubernetes network policy only allows a namespace to talk to itself, then you would do helm install ziti for each namespace that you wanted to expose something, because the one that you installed in the default namespace would not be able to quote host any of the cluster workloads that are in a different namespace.
Okay.
So yeah, you could slice it up any way you want. Another option is to use the sidecar pattern, which is one of the guys in this diagram here.
We're gonna have to start talking about Istio. We're gonna have to start talking about Istio.
We don't have to. We don't have to. I mean, this is all interoperable with Istio. You don't have to choose between Ziti and Istio, but they are solving some of the same problems, right? But you probably want Istio as a bespoke service mesh, and you probably want Ziti for application-specific networks.
Yep.
All right.
Good answer, by the way. Good answer.
Thanks.
Good stuff.
All right. So I'm going to pop back into the console here, and which tab is it? Okay. So this Ken cluster exit is my helm install ziti host identity. That's the one that's running in my cluster. It's got access. It can read cluster DNS, right? It can find services there, anything I want to describe. So let's make a service for httpbin. Do this again. Simple service. This will be Ken rest test.
Oh, I like that rest test. That's
Rest
good. That's
test.
good.
So
Like
we'll just let all of the clients that have access to the welcome wagon policy access this service as well, and we'll call it rest test.kentest. That's going to be hard to remember, isn't it? How about just rest.kentest, port 80, and we're using a ziti host there, so we'll say that one has, when I did yours, I used the app mention form, and this time I'm going to use the hashtag role attribute form just to show you can do either one.
Okay.
So if you could use hashtag role attributes if you wanted a whole bunch of endpoints to host the same service, and they would all be doing the same. Like whenever they received a connection, they would be doing the same protocol DNS and port lookup to find the thing.
Okay.
And so in my case, it's httpbin default svc is the minimal there. We could put the closer local, but that's what it's gonna search that cluster name, cluster zone anyway, and it's on port 80. So short and sweet, httpbin, create that. And so now if you were to do use like curl and excuse me, on your computer, compose an HTTP request to rest.kentest/IP, you should get back a response.
All right, let's see. Bring my screen back in here, and then we'll do curl http and already forgotten. I'm sorry.
It was a
And
rest.test.
Rest.kentest.
Rest.kentest. I'm glad you're here, Clint. I keep forgetting these details. Yeah, /IP.
/IP.
Yep. There you go.
Nice.
So let's make a
Nice.
mental note of that IP address so we can do a little comparison back on my screen. Lots of flipping around here, but we're wiring up multiple disparate things, so it's kind of necessary. So if I say get pods, we look at the IP address of my ZT host pod. Is that a match?
That is a match, Ken.
All right. So
Huzzah!
my httpbin container running httpbin says, hey, I just got an HTTP request from here, which is the exit inside of my cluster namespace that's hosting that service. Does that make sense?
Absolutely. And by the
Cool.
way, I forgot to do this. I was going to do applause. You know, it works.
Yay. All right. So if you want to go there, I have we could whip up a Kubernetes deployment running in your cluster that
Okay.
just runs that curl command over and over.
Sure.
So to show, like, to get your it could be running, it'll run that curl command and basically exercise that same path that that you just did from your running curl on your terminal.
All right. How would you like to do that?
So I think what we're going to probably need to do is use this sidecar pattern. So I'll bring up the whiteboard real quick so I can point at it and show you what we're doing. So right here, we're going to install a multi-container pod in your cluster, just using kubectl apply -f with a sidecar deployment demo that I've got that I'll send you the link in just a second.
Perfect.
And so what that'll do is it's going to have two containers. I'll just bring it up so you can see it here.
I mean, I'm
So
willing to write a deployment all by hand if you want me to sit here and hack on
it's
some
all about
YAML
how
for an
much
hour.
time you got.
Yeah, right. JJ, you forgot 2 spaces. Why is this not working? JJ, it's 3 spaces. It's not 2.
That can be a little tedious. Let's zoom in a little bit here. So we'll be telling your cluster to run 2 containers, get a vanilla CentOS test client, and it's just going to run this shell loop while true, do curl localhost, and then inside the same deployment, we've got ziti here running as a proxy. So we've tightly coupled the configuration of our ziti piece and our application piece, where the shell loop running curl is just a stand-in for an arbitrary application sending HTTP requests. Does that sound good?
I just like the skeptic in me is like, this sounds great and all, but like, I mean, I'm stuck on the overhead problem of like this
Yeah.
like if I have a massive app and I'm putting the sidecar against it, now it's sitting there in front in the pod for the communication to go out through this tunnel. Like it's
Right.
just I'm like
It worries you.
The
yeah, it
overhead
does.
really, I mean, like in practice, I never ever notice any overhead. We don't do really latency sensitive type stuff, but we do have, there's a chat app called Mattermost. We run Mattermost over ZT all day long. Like I had that running before our meeting here. You never notice it.
Really?
Never, you never. I mean, really, and I'm not even lying. The first time, what you'll do maybe is maybe the very first time you ever try it, where the first path is established, there might be a tiny bit of latency in that. But honestly, after that, I never even notice it.
Amazing.
Yeah, it's. I mean, it's not like Networking is terribly computationally expensive, right? It's not like you need a lot of memory. You don't need a lot of disk. It's just CPU. So modern CPUs can eat a whole lot of bandwidth and just shovel bits across that network plane real quick. So it really. Honestly, I have never even noticed I'm running Ziti.
Nice. All right.
Well, what would be a good way to test that, JJ? Like as you're, or if we're being authentic with that worry, like what specific kinds of worries does it conjure up, and what would be a good way to start addressing that?
Maybe that could be our next stream.
All
Hint,
right.
hint. Something a little bit more. Maybe find some like real-time Firehose or something like that. I don't know. Just kind of it'd be really interesting because if you can prove that like, I mean, obviously Mattermost is actually a really great example because it's
Yeah.
real-time chat, right? Like that's really important to see. But there's other ones that do like, obviously more, and running that on Kubernetes and showing that ZD puts little to no overhead, like just to see that as a proof, that would sell so many engineers that I
Are
know
you
to
looking
be like,
for like latency type of overhead or CPU overhead on the boxes? Like what sort of overhead are you thinking when you say overhead?
well, being that I'm, sitting the cloud native ecosystem, it's always usually the latency, and especially in a multi-cloud conversation, right? Like the one thing you need to worry about in this world is um is when you have to cross the internet to do stuff, right? Like pull stuff down or whatever. And the nerd in me is just like, sounds so cool, it makes so much sense. But if I'm running my production environment and it takes 30 seconds for to get the page to do the thing, do you see what I mean? Like it's
Yeah, in fact, I just sent you in the private chat a blog post that our CEO wrote why we switched to Mattermost, which came out really relatively recently. I do believe it's got a little overlay diagram in there that you could look at if you were interested. It just shows you that we run a couple fabric routers across the cloud, and I think we send it into Amazon, and we run our Mattermost beside there. And if I fired up Mattermost right now, Ken and I could just chat if you wanted, but I could send him a
all
file.
right.
You know,
That's awesome. Well, okay, I mean, I'm gonna be like you know
oh,
overly
love it.
annoying
No,
here.
no.
It's just
It
it's
really is that
that
easy that it's almost hard to believe. Like Ken and I were talking about that beforehand, where I was like, "Hey Ken, if you're going to do this demo, how do we prove that these ports aren't actually open somehow?" Right? Like you already started out by doing exactly that, so I totally get it.
Yeah. And I'm sure that you're not alone, JJ. I mean, all of us have been on this like journey to figure out how this stuff works and see what kind of problems we can solve with it. And I think there's a lot of undiscovered territory about what we'll be able to do with it. But we got to start with these reservations, and just sort of
yeah.
unlearn doing it the hard way.
It took me so long to learn natting, and you're taking natting away from me. That's not very
Exactly.
nice. Not
It's like
very nice.
Stockholm syndrome.
Exactly. Good call. It looks like there's an actual secret in here for the JWT. Do I need that,
Yeah, we're
or
gonna do
is
we're
it?
gonna do kubectl create secret from the file, the new JWT that I just sent you. It might
Uh,
sound like there's a lot of JWTs flying around, but it's important to have a separate identity for everything so you can do really specific permissions.
do we need to create that secret beforehand, or can I go ahead and apply the sidecar?
We'll do the create secret first.
Okay.
One thing I'll add on to what you just said there, Ken, I disagree that it's important to have a different identity. It's important to not transfer that identity. So the JWT allows your identity to stay on the machine that does the enrollment. You could choose to pick your identity up and move it somewhere, but that is
Mm,
not acceptable, right? You should not be doing that. So the reason why he's sending you another one is because if it's on a different machine, then you want to use a different identity. If it's on the same machine, you can reuse that identity. And then you're using the actual ZD network itself for the authorization tier. So I would say it does depend. If you have an application itself where it's baked in, you most likely will have a separate identity just because that will be part of your app's enrollment process. But never transfer the actual certificate or private key, technically, I guess, that gets created from the enrollment process. That's the real key there. No pun intended.
great secret.
Do you see the
Sidecar
hint that I
WT.
sent you? for the.
Oh, perfect.
There you go.
You're already on top of it. Jeez. It's like you've done this before.
Obsessively.
Exit 1.jwt.
Which file directory? Did I spell it wrong?
It's a client one.
Oh, is it? Did I name it client?
I don't think you named the file difficult enough. Like it could have been more characters. And
Sorry. It is client one. Yeah, that's right. So
apply -f. And then again, if you didn't see earlier, I did bring up this YAML because he did ask me to wget something randomly from GitHub. So, just checking, just trying to do the right stuff. Not that I don't trust you.
I mean, it is production.
Yeah, thank you.
And it's extreme, so.
Exactly. See, Clint gets it. All right, get pods, and then there we go. We are pending right now.
So this is a multi-container pod, right? Because it's using the sidecar pattern. So we've got a supporting container and an app in this case. It's just a list of containers in the deployment, but we've only got 2. So if we look at the log coming out of the one called test client, we should be seeing that same IP address that you did from the /IP.
Oh yeah. Okay. So I'm showing some words here. Get PVC.
Oh, I missed it.
Yeah, where you got to wait for this to pen. It takes a couple minutes. Yeah, it takes a couple minutes.
Yep. Yeah, I forgot to ask you if you had a default storage class set up.
Yeah, it takes a minute.
Okay.
I've seen it quickly as taken 3 minutes. Sometimes I've seen it take
I'll
many
explain
more than 3.
I'll explain why it has a persistent volume claim in this case. It's it's 2 containers, right? And the tunnel, the ziti container that's providing the proxy on the localhost interface on the loopback. That one, it needs to take that JWT file, which is a secret, and it needs to enroll with that. So that's a single use token that it's going to use to do that handshake, and it's going to generate a private key and get a certificate back, and it's going to store that in the PVC.
Got it. I mean, that's very reasonable. It's just, the cloud and the weather on the cloud sometimes doesn't always work how you want it to.
Yep.
Yeah. Or internet weather. I'm sorry. No, internet weather. What was that term?
Internet weather. Internet weather.
Can depend.
I'm gonna own that. I'm gonna continue that narrative or term. There we go. See, it's like I almost timed it perfectly. We got PVC. We are bound, so we can get pods.
Good. So now the deployment has storage, and it's no longer pending.
There we go. Started the container. Okay,
oh yeah, there you go.
And we want to see the ZD tunnel.
Test client.
Sorry.
Let's check on ZD tunnel. Looks like it's not listening. Why you no listen?
Reflect server is not specified.
We got to modify. Let's delete your deployment and modify the YAML.
Oh no, we gotta wait. We gotta wait again. That's fine.
It might actually be able to use the same storage because it's going to call for this. If you delete the deployment, the PVC will still be there, I think.
No, not on IBM Cloud.
Not an IBM Cloud. Okay.
Yeah, we're gonna have to do some more dancing and do a little jig. Maybe get Clint to do a little dance in the background there for a few minutes.
That's a good sport. Well, you had
AJ didn't even know what he asked for when he said.
There you go.
You had your guest a couple days ago singing the clown song.
Yeah, it's true. You're not wrong.
That happened.
All right. Where am I changing?
So in the YAML, there's a hard-coded name of the application the ziti service name. So where are we? Scroll down a little bit. I'm looking for, it'll be a in the args passed to the container. There you go. Image, ziti tunnel, args, proxy, and then httpbin. What does that need to be? That needs to exactly match the service that I created for you, which we named the Ken REST test. So I'll put it, yeah, it needs to be upper Ken space, sorry, just upper K space, uppercase REST, and then space, and then upper T for test.
Brilliant.
Now it's right.
All right.
So we've configured ziti, the proxy, to bind that service.
That is the service on the other side.
On my side, right?
Yes, as you see that as I do a get service here, we don't have that service on this side.
Right.
Just to make it very clear.
Yep. And I'll start taking a look at the logs for that. Let's see.
Okay. Just give it a minute here, or 2 minutes maybe.
Now, if your application itself had that strong identity baked into it, you wouldn't need to be following this sidecar pattern. You would just deploy your app inside of Kubernetes, and then it'd be able to access the ziti network the way it would normally do it. We just need it here because we have, as Ken said, we've bound that service using a feature of ziti tunnel called the proxy that allows you to send the traffic to that machine, which will then traverse the network.
Yeah, that's really, like, it makes sense. Then if you have your legacy application and you're trying to zitify the rest of it, and you're still cloud native running on Kubernetes, throwing in this side. So yeah. Oh, mine's racing again. Nice. Like this is all. It's opening up so many
clicking.
possibilities. Yes, it's
Yeah.
opening up so many possibilities in my mind. Like this is
That's awesome.
This is really fun. This is fun.
I wish I could see a log message coming from the REST server to say, "Hey, I just answered this." Maybe there's a way I can
Could use TCP dump.
httpbin. Well, it's running on the cluster, so I'm trying to think if there's a way I can configure httpbin to give a more verbose output, maybe with an environment variable. Are you waiting on that PVC to come through, JJ?
We got an error. Nope.
Can you make your screen bigger again?
Oh, sorry. I thought I was doing that. It looks like we got an error. Something is not happy with us.
Okay. It doesn't say what it is.
Yeah. If I do K logs ziti tunnel.
Yep, that's the
Oh,
one.
there it is. Ziti tunnel PID unbound.
Invalid token. So the JWT's been burned.
Maybe we got them mixed up. Maybe the one that you used to create the secret. Maybe
he's registering a second environment, right? Like, so that JWT that you sent him once is no longer valid.
I can definitely create another one, and that would explain it. But when I did this earlier, I was able to reuse the PVC. But that's where
I can tell from that error, failed to enroll. That means so that enrollment process is taking that one-time token, that JWT, using it and then burning it. So if you have removed your storage and you need to re-enroll, which
Yep.
I think is the difference, then
Yep.
you'll need a new JWT in this case.
All right, so I'm going to make JJ cluster client 2. And as the network administrator, I will send that over. It'll come through as an email because I'm going to use the endpoint share feature here.
All right.
Sorry to type your email address here.
Yeah, it's fine. It's awesome at IBM.com.
Awesome.
It really is awesome at IBM.com. It comes
That's
directly
right.
to me.
That's right. That's the one that you. So if you were registering a mobile client, just to show a neat feature here, you could just scan the QR code, and that would load the
Nice.
identity right in and do that whole
Now-
PKI handshake.
Now I've already gotten your identity.
You could have, if you wanted to, you could steal it before you.
I certainly could have. I should have.
Yeah, because it's single
Yeah,
use. Yeah.
I've actually had people on my stream watching have screenshotted the token key and then typed it in by hand
Yeah.
to log into the clusters that I have just to
Just to
mess
prove
with
a
me.
point.
Yeah, and I'm like, all right, come on, all right, I get it. Like I'm deleting the cluster after the fact. Like it's like I realize I'm not being the best here, but now I'm getting all paranoid if I do any of this. Anyway,
I'll teach you to use sandboxes.
yeah, exactly. Still waiting on. Unfortunately, the email is nice and speedy over here at IBM, so it's going to take a minute.
Is there a way for me to upload an attachment in here, send you a file directly?
No, unfortunately, there's not.
You could go crazy and paste the JWT right into the chat.
I could. Yeah, we could do that.
Oh, here it is. I got it.
You got it. Okay.
Yeah.
Good old email, the original bottleneck.
That's right. Let's see here. So we'll go ahead and grab that command again. Copy. I'll bring my screen over in just a second here.
All right.
Really? I hate computers. Copy. All right, and then I will bring myself back in here. There we go. So if I run this,
create secret. You'll have to do delete secret.
I thought I did. Did I delete the wrong secret?
Oh yeah, you deleted the wrong one, but that's okay because I don't think it needs that one anymore.
All right.
Thankfully, we're going from this cluster to a different one.
Oh yeah, whoopsie. All right, and then get pods. Okay, should I go ahead and delete this deployment too, and then create the secret again? Is that the better idea here? Or if I add the secret, will it all of a sudden work?
Yeah, if you create the secret and then do a replicas equals 0 and then bring it back to 1.
No, let's just delete it. This one.
Then that would cause it to restart.
Like in the real world, you'd be never doing it that way, right? Like we don't have a workaround for.
Yeah.
Like this is the real world is you'd give it a brand new key, you delete everything, and bring everything back up because you'd want it to be in the clean state, right?
Right.
Or at least that's what I'm assuming. I'm hoping.
Well, it's good that your IBM Cloud with OpenShift has a default storage class. I don't know if OpenShift always does, but it certainly is good. That's one of the basic things that I certainly hope for with any kind of Kubernetes on cloud is that you get that storage from that cloud.
All right. Clint, need another gig, buddy. That's good stuff. So while we're waiting, we have a handful of people watching live. If you have any questions or thoughts, please don't hesitate to throw those in the different chats we have. I would love to bring it up and answer some of those questions while we patiently wait for our what is it, NetApp? That's a story thing, right? NetApp. Our NetApp decides to make a 20 gig partition for us. It's NetApp, right?
That'll be plenty of space.
Yeah, for one token. one token.
While that's loading, I'll pull this up to explain the difference between an app mention and a hashtag roller group. You probably saw us throwing around these app mentions, and it's just like it is in social media. Like if you're on Twitter and you want to at mention somebody, that's the difference, right? If you're gonna use a hashtag for this is attribute-based access control. So we use this in two main ways. They're only subtly different. We use it for permission, granting access to the services, and then we use both of these also for configuring the routes. And that's overlay routes as distinct from IP routes. It's still IP packets flowing through them, but it's on the overlay. So that's earlier when we said that you might want to optimize the delivery of your application for particular circuits or particular clouds, particular geographies. You can do that with route configuration using these same app mentions or hashtag role attributes to form policies for your endpoints to go on and off the mesh.
That looks right.
Yay! All right, so now
Huzzah!
your cluster with a little stand-in, like a little substitute basic app.
Thank you very
And
much.
that's a cluster IP inside my cluster. That's a pod IP in my cluster of the ziti host, which is reaching out to an arbitrary server, a basic REST test server.
That's pretty cool. That is like we really did create a massive overlay network between two Kubernetes clusters, two laptops in less than an hour, and it just worked. Right?
Yep. And the only things
Yep.
that we did in advance were we spun up the two clusters. So I used the OpenShift installer. I needed to create an IAM credential. I used the OpenShift installer on AWS. I just said OpenShift install. And it took about 30 minutes, but it was pretty painless. And you did the same thing for IBM Cloud. And then the last piece was I went to nfconsole.io, which is the NetFoundry web console /signup. And I started a free trial and I just clicked create network. And that created the control plane and the fabric and all that stuff.
This is awesome. It truly is. Well, I mean, I like ending on a high note, and this feels like it's as high a note as we
can
get.
leave it there. Yeah.
Yeah. Do y'all have contact information? So if anyone has any questions or thoughts, what's the best way to get a hold of y'all?
Yeah, I'll just put some info up on the screen here, but you can certainly reach out to us through NetFoundry. Let's see, buttons.
There's GitHub. There you go.
Yep, there's also the ziti.dev website for all the open source stuff and the SDKs, direct access to the team.
GitHub.com/OpenZiti is where all the code sits, so you can go out there and peruse that all you'd like. And there's also a link from ziti.dev to the discourse. So if you want to post any questions, just random questions, you can choose to put it into GitHub if you want in an issue, or you can use discourse and just have a chat. Those go directly right into us. You'll see Ken has been active out there. I've been active out there. We're really responsive. So we always enjoy getting feedback and answering questions.
Awesome.
Yes, we do.
So I'm not saying tongue in cheek. I'm actually serious here. It sounds like we need to have a follow-up here in a little at a time where we do the self-hosted one that Clint, you linked earlier, and there was something else that we were like, hey, that would be great for a follow-up. What was that?
That was the throughput and overlay, the overhead.
Yeah,
the overhead.
Or just exploring the broader question of like, how do you decide whether to optimize for like whether to maximize the minimize the overhead or maximize the programmability, because there's questions there are questions here. We spent a lot of time thinking about this, right? And
Mhm.
there's a reason why we went this way, and we think that there are some very appealing trade-offs, and they're usually not as much of a trade-off as you might fear, because
Yeah.
we just sort of learned the hard way, trial and tribulation, right? And coming up in systems and networks, that you have to take these things into account, because those microseconds add up. But
Up there.
these days, with resources being what they are, and costs being what they are, it might make sense in a lot more cases. We think it does. Feel powerfully certainly that it does make sense in a lot more cases to optimize for that programmability.
Mhm. Nice. Rock on, man.
And we can see Mattermost too.
There you go. There you go. All right. Well, gentlemen, how about you say goodbye to our audience?
Later, all.
JJ. Yeah, thanks for having us. It's been great.
Thanks everyone for joining, and bye.
Bye.